And we are live.
Welcome everyone to today's Zip Talks with Mr. AJ Foster and Mr. Eric Grajales. My name is Shreya and we'll be talking about tips and tricks about electronics and more about the FTC State Championship.
Yeah, so just to get started, I wanted to ask you guys a question about like the IMU systems in the robot. I know it's a big problem that we've had in our robot, and we've seen on the forum a lot of other issues there. If you guys have any solution for it.
Yeah, so I'll just get started on this one. There is a known issue with IMUs inside of the Rev Control Hub. So if you're not familiar, the Rev Control Hub, depending on when it was created, when it was manufactured, has one of two different types of IMUs right in the middle of the unit. And this is what tells you really nice information about like gyroscopic data, how you're turning. It has a compass sensor in there as well, and it can tell you about the acceleration. And it can integrate all those pieces together to give you an idea of how your robot is moving on the field, which is really nice. But there's a known issue with it right now where the IMU can reset, sometimes in the middle of your match. And basically what happens is when it resets, it starts giving you back some bad data that the software that's running on the control hub can't understand. And it can cause the program to crash or any number of other weird things to happen depending on how you're reading that data. So there is, as I said, we know that there is an existing issue. Rev believes that this could happen to anyone with any of the two types of IMU that might be in the control hub, but it is definitely more common with control hubs that were manufactured a bit more recently, that have the newer IMU chip inside of them. They have a software fix for this issue that can help to resolve it, but it is not yet available publicly. And I don't want to give out the email address of the person to contact, like just to the internet. So what I'm going to encourage people to do is if you're having this problem, reach out to me in any way that you see fit, whether that's in a comment on YouTube or on the FTC Discord. I can help connect you with someone who can send you that software patch so that you can try it out and see if it helps your team.
Thank you. Any opinions on, for now, we've been looking into external gyroscopes, maybe shutting down the IMU on the control hub and using something else. So would that be a viable fix?
It is, because as you know, the software rules and the hardware rules for First Tech Challenge are pretty open. So you can connect up another piece of hardware, another sensor if you want, even though you already have one embedded in the control hub. So what I would probably recommend is to go on Adafruit. That's a website where you can buy parts, sensors especially, and look for an IMU. It's called the BNO055. This happens to be the exact IMU that was put in the earlier versions of the control hub. So it's already supported in the software, and you're going to have a relatively easy time working with it. The one very important thing to remember is that you should not plug it into I2C port 0 on your control hub. You have 4 to choose from. Make sure you don't choose port 0, because if you have an older control hub that has that exact same IMU, they might fight. So just choose any of the other 4 ports, and that will be probably the easiest way to use an external sensor for that purpose. Eric, do you have anything to add in? Any recommendations? You are muted.
I'm sorry. Yeah, I fixed it. I believe that that is one of the suggestions that I've seen on Chief Delphi also, and on the forum post. And the BNO sensor, I mean, it was one of the original ones that we even used before the Rev expansion hub. So it was something that was it's a known commodity that I believe will help a lot of teams.
Yeah.
So.
Yep. And just to add one other note to this topic before we wrap up, part of the reason why this might be happening is electrostatic discharge that's occurring to your robot. So any of the standard things that you might do to help mitigate that on your robot, like using the resistive grounding strap, or asking your tournament hosts if they're, using staticide or things like that to help mitigate the issue. Those can also help here. We don't know that will 100% fix the issue, because teams have been having pretty wild variations in experience of when it does and does not happen, but it will help.
Thank you for your input there. In fact, like, speaking of wiring and stuff, we've been looking into different like wire management strategies in order to organize the flow of wires better and make like troubleshooting on the robot easier as well. So any like suggestions? We've been currently using blockchain. That's one of our newer technologies that we've been using.
Eric, do you want to get started?
Yeah, I believe that wiring is probably one of my issues that I always see with a lot of robots. The other thing that you can do to try to mitigate things is don't put your control hub directly attached to any metal if possible. I try to either put it on a piece of wood or some type of Lexan. A direct connection to the metal pieces is something that you want to try to avoid if at all possible. The other thing to remember with those gyros is you want to keep them in the center of the bot, the center of rotation. So to get the most accurate information out of those. For wire management, I've seen a lot of people use the loop. That's not hook and loop. It's the plastic sleeve type of functionality. That seems to work fairly well for a lot of teams. In my case, we used, believe it or not, a lot of zip ties to manage and route all of our wiring throughout the bot, and just to make it easy. The other thing that I always tell teams is make sure that you have the capability of being able to replace a wire quickly during a match, because if something, it gets clipped, it breaks, something else happens, you want to be able to quickly get to your robot elements and be able to replace those throughout the system.
Yeah, that's something. I believe you're talking about the cable sheathing, the plastic around the chains. We actually used that 2 years ago in Freight Frenzy. And a big thing with that is, like you mentioned, it's really hard to access the wires because the whole thing is covered. But so, like, two things that we found out that's quite recently is a different type of cable sheathing, which instead of being like a full cylinder, almost like a tube, it actually can unravel sort of like a scroll, or like a just like a roll of paper. So that way we can easily access the wires. And also, we're not using it this year, but last year we used cable drag chain. This was like super simple to like pry open the little flaps, and it's also really easy to like just keep all the wires compact.
Right.
I think in general, it's important to realize that when you're designing the robot, things are changing rapidly. Flexibility is good, but in the week leading up to a tournament, that would be a good time to sit down and say, okay, we know that things are stable right now. We're not going to be moving anything in a major way in the next few days. It's time to go through and just tighten down all the wires, make sure that they are where they should be and they're not going to get clipped or anything like that. Because I think it's really easy to just kind of leave it a mess and then get used to that mess throughout the season. So I like to say that the week leading up to any of your tournaments is a time to just, take a step back and let's make sure that everything is going to be reliable for us.
Right. Yeah, and to that point also, I've seen it a lot more this year than I've seen it in the past. Robots that have a lot of extra wiring, so they have this spin of loop of wiring. I'm exaggerating here, but it's 10 feet of wiring in a loop that's sitting on top of their bot. That's not a good thing. You don't want to be able to have that. So, just go through and, like AJ says, it's time to tidy up and clean up some of those runs and make sure that they're connected properly and tied in.
But when you're doing that, don't make it too tight.
Yes,
because
strain relief is a good thing.
Strain relief is like the key idea that a lot of people don't understand what that means. So just understand that you want the main part of the wire going across your bot. You don't want that to move much because that's recipe for trouble. But when you get to the end of the wire, the part that actually goes into the control hub, like just as an example, the power cable that goes into the control hub, you want to leave a little bit of slack there. So as your robot is moving, as it's running into things, as people are running into you, it's not pulling on the end of the wire and possibly pulling it right out of the hub, because that happens a lot. And over time, even just the movement of not even an over tight wire, but just a little bit of tightness on that wire is going to cause it to move back and forth. And over time, it can cause it to become the actual connection where it meets the control hub to become loose. So just adding a little bit of slack at the end, strain relief, that will help a lot.
Right. And that's also true at the motor ends or at the servo ends, all of those places. You want to make sure to have strain relief there too. And talking about that, especially on servos, if you have a servo extender, one of the tricks that we did is if you use a little zip tie and wrap it around both ends so that that connector stays always tight, that's something that's good, because there'll be instances where the robots will get caught. They'll grab that cable, they'll pull the servo extender cable apart, and you want to try to mitigate that.
Yeah, that's something we tried last season, where we like kind of looped the zip tie around the wires, but we found that it kind of like bends the wires and it splits it in a weird way. So what we actually started doing is, like with the servo extenders that you mentioned, we just wrap like duct tape or like gaff tape around them, so it keeps it together without like pulling it apart, or like electrical tape too.
There's small zip ties that work fairly well.
Yeah, that worked too.
Yeah, you got to experiment with it, but yeah, just something to keep those together.
Speaking of experimentation, so in vision, like we've seen the new Husky lens come about, and we've been looking into trying it out. Of course, we won't be trying it out this week since it's the week of states and stuff. We want to stay consistent. However, it is an option that we're looking into to optimize and innovate.
Yeah, I always recommend teams during the summer or during their off season experiment with those different types of sensors, different motor configurations, different drivetrains. That's a great time to look for alternatives, to see how you can improve, to see what works for you. It seems like over the last several years, FIRST has gone to these the markers type of objects and the April tags type of systems. So anything that that you believe that can help you with identify that and use that during autonomous or during the teleop portion is a good thing to go try and study and test.
And it's a good idea to get comfortable giving yourself a setup where you can test these things not on a robot. So get comfortable with the idea of taking a control hub and a battery and your Husky lens or whatever it is you want to test out, and get it all wired up just sitting on a table. It doesn't have to be like on your robot on last season's bot or anything like that, and just kind of get used to that. It's a practice you have to practice at in order to feel comfortable doing that, and to set it up in such a way that it's nice and easy and nice and quick for you to do those sorts of tests, because the faster you make it, the more likely you're going to do it.
Right.
So the state's championship has been coming up in Florida recently. So we'd like to know any like heads up for teams that are coming in as rookies this year, and sort of how will the competition be?
Yeah, I have a presentation that I think will answer a lot of those questions.
Oh, what are you doing?
So I'm going to go ahead and present something real quick.
I don't have
so let me know when you guys can see my screen.
I can see it.
I don't
Okay.
have anything to
So, one of the things I always want to remind teams is when you're going to competitions, you want to remember to have fun. You know, enjoy the day, have a good time. You're there to compete, but you're also there to meet new people, to exchange ideas, to do different things, and you want to have a good time with a lot of that. Um, Another thing, like when I talk about prepare for your competition, I this is one thing that I always tell a lot of teams is read the rules, read the rules, read the rules. Um, I I don't know how many teams have come to competitions that haven't fully read the rules or understand them or how the game actually works. So having gone through all the various rules in the system and knowing them will help you as a team in case of during a match the refs didn't score something correctly. There was some penalty that they didn't notice. It's something that gives you the ammunition to go to the question box. And since you have the rules and you understand them and know the rules, you can present those to the refs and try to uh, mitigate the issues that may have occurred. The other thing is read the game forums post, especially all the parts about the rules of the rules of the game and the various robot parts. Are they legal, not legal? How can you use them, not use them? That's one thing. This is one of my pet peeves with teams. Charge your phones, your driver stations, all the robot batteries. I don't know how many teams come to events with their batteries almost empty, or basically they have to charge them at the event. You don't want that to happen. The other thing is there's a tool that I think Andy Mark sells, and I think a couple of other places sell. It's called the Battery Beak, and that can be used to test your robot batteries. And what that will do is test to see how well your batteries hold their charge. So you want to make sure that you have those batteries tested and know which ones are the good batteries and the bad batteries. Typically, what we would do is we would use the Battery Beak to test the batteries, and any battery that came out as bad, we would use during practice type of scenarios. The other thing to make sure you have is make sure you update the laptop with your latest code, the latest SDK, everything that you need. During events, I have seen laptops where Windows updates start. So if you can run Windows updates beforehand, make sure you do that. And the other thing is make sure that laptop is fully charged. If possible, bring a backup laptop, with all of your code and everything on it. This one's another thing is backup. If you have code in blocks or Java, back it up to a thumb drive and make sure you give it to more than one person. I mean, it's the more the better, or you put it on the cloud drive or something that you can get to or people can get to. Before you head over to the competition, you want to make sure you organize and pack all of your tools, your carts, everything that you're going to be needing. I always say this: zip ties are your friend. No pun intended. So make sure you have all the necessary connectors, cables, hex keys, screwdrivers, nuts, bolts. Basically any tool or component that's going to help you repair your bot. I've seen this happen before in the past where they forgot their presentations, their engineering notebooks, displays, giveaways. Anything that you're going to need to talk to the judges, talk to people coming to your desk, to your table. It's always good to make sure you have all that there and ready. This is something that I tell people, and they don't believe me, is stay well hydrated. Make sure you drink lots of fluids. I have seen cases where a student has, basically almost fainted because he wasn't drinking any water or drinking any juice or anything else. So especially when they go to the field and they're hyper and they're just ready to play and they just, it just happens. Also, use the hardware and software inspection checklist before you get there so that if there's going to be any issues during inspection. We want to try to avoid that as much as possible and make sure you get through the inspection process quickly and efficiently. The other thing, and I tell this to all the teams that I meet is, make sure you practice with your bot. Make sure you put obstacles in the way. Try to run different configurations. Make sure you practice all of the different autonomous modes that you have. Test different scenarios. Come up with ideas for all of that. So those are some of the things that I recommend preparing for competitions. The other thing, at the competition, this is something that I always tell teams is, build a pre and post match checklist. You'd be surprised at teams that come to the field ill prepared. There was a team that came to the field without their driver station. We're like, you need joysticks to run the robot. The robot's here, but the joysticks aren't. So just make sure that you have all the necessary items that you need. And especially if you have multiple drivers, sometimes they don't talk to each other. So, if there's any robot setup information, how to place the robot on the field, where the marker needs to go, if the marker needs to be in a certain direction, you verify all the different things on the robot. If you're using rubber bands to launch, the plane, make sure you check that. Make sure you check the plane position. Is it where it's supposed to be? You'd be surprised, which way is the front of the bot. So when they place it on the field, it's facing the right way. Make sure all of that. And if required, check your vision system. A lot of teams will place the marker at the various points on the field and make sure that they could see all of those properly and that it's registering in their system. Pick the appropriate autonomous and teleop modules. Are you the red side? Are you the blue side? Are you in the front part of the field? Are you in the back side of the field? Do you have any delays? All of those types of things that you want to do. And then after the match, you want to make sure you check your robot out and make sure that it's ready for the next event. Check the belts, check the nuts and screws. The wheel set screws is something very important. During matches, your wheels are running a lot. I don't know how many times I've seen wheels fall off the bot onto the field, because they didn't check those types of things. Check your elevator or any other scoring mechanisms. I know there's a lot of elevators that run on the wire or cord. Check those out. Make sure that everything's good. Check your batteries. Just basically make a checklist to make sure that everything is needed for setup during a match and after a match is verified and checked off for your teams. And then finally, during a match, for the drivers, if something goes wrong or you're having difficulties, just signal the FTAs. We're there to help. We'll try to make it as easy as we can on you. At the end of the match, remember to hit the stop button. That'll help out the refs and the FTAs. And then if you have a game element stuck in your bot, just make sure you return it back to the field. And this is something that I don't believe a lot of teams do very well, is have team members watch matches and scout other teams to figure out what other teams complement your robots that would work with you during an elimination. Create a list of at least 4 teams that you would want to pair with during an eliminations that you can use. So that's something that a lot of teams don't do a lot of scouting. And again, remember, FTAs are there to help. We'll help you in any way we can. If there's issues happening with your bot, there'll be CSAs at the field to help you out. AJ's really good at that. So we'll try to help as much as we can. So that's my rant. I'll go ahead and stop.
Thank you for the rant.
Yeah, thank you for all this advice. I'm sure many rookie teams will find this very helpful. This is definitely very organized and thorough approach to it, and we'll definitely be sure to implement the wiring tips and tricks you've shown. As a matter of fact, I wanted to maybe ask about, are there any new upgrades to the Android version or the Control Hub software?
I did see that version 9.1 of the first Tech Challenge SDK came out fairly recently. And my understanding is that it is mostly bug fixes. So if you've been having any interesting issues, you may want to take a look at it and see if it addresses anything that you've been seeing. When we get to around this time, we're about a week away from the Florida Championship. It becomes a bit dicey. Like, do you upgrade or do you not? And at this point, like within a week of the event, I would say if you're not experiencing any troubles and if the items in the README don't stand out to you as being like, oh, this could really cause us an issue if, the problem they say is there happens to us, then maybe you leave it alone. And what you have to make sure is that if you are on version 9.0 right now, that you have that version on both your robot controller and your driver station, because maybe your driver station does an auto update to version 9.1, but you'd rather have those versions match. And especially if you have versions that work for you when you're this close to a major tournament. If you're a bit further away from your regional championship or just in general throughout the season, I encourage everyone to upgrade to the latest version. Make sure you upgrade both your robot controller and your driver station. Give yourself some time to test it out. Make note of anything weird that happens afterwards that wasn't happening before, or if there was anything that was happening before that isn't happening now. So if you, for whatever reason, downgrade in the future, you know what might happen as a result. But in general, the latest version is the best if you have time to test it.
Right. And also about that is make sure that you update, if you're going to update all of your driver stations and all of your robot controllers, not just your main one that you're using now. So if you have backup ones, make sure that those are also have been updated and tested with your system.
Yes.
So,
it's important because there's a lot of teams that maybe they have an older Android smartphone that they used to use as their driver station or robot controller, and now they have it as a spare driver station, for example. Right. And you usually forget to update those devices. And then in a pinch, if your battery's dead on your main driver station device and you use that one, it may not even work for you if there's been an upgrade in the protocol, the communication between the two versions. So you have to make sure, like Eric said, that you actually test all of them.
Yeah.
Okay. Is there thank you for all this advice. It's for sure going to be helpful in the upcoming week. Is there anything on the hardware side that we'd want to talk about, maybe electronics wise, wiring or control hub and expansion hub? Maybe Arnav can talk more about it.
Yeah, just one question I had about the driver hub, the little tablet, is one issue that us and another team, that one, have been seeing a lot of is sometimes when you put it down on a table super hard, or if you just drop it gently, the battery disconnects. I was wondering if there's any way to avoid this, maybe packing tape around it or just any solution.
I had a feeling this might come up, so I even unscrewed my battery cover in preparation. So one of the known problems with the driver hub is that the battery, I took the battery cover off so you can see the actual battery. It sits in a compartment, but the battery is slightly smaller than the actual compartment. So it can move, especially up and down. So what can happen is if you are, like you said, setting it down a little bit hard, you can actually make the battery move inside the compartment enough that the contacts actually come disconnected. So it just loses power. I'll take the battery out real quick so you can see the contacts are at the bottom of the compartment, and they're pretty small. They're just little springy pieces of metal that the battery is supposed to sit down in. And if you just jostle it too much, they can come disconnected. So the advice that we give people, if you reach out to Rev support, they can send you a piece of foam that actually goes inside of the compartment and helps to push the battery down against the contact so that this doesn't happen. But if you don't have time for that, maybe you're going to the Florida Championship in a week. What you can do is take 2 layers of gaffer tape. This is actually 2 layers of tape It's just the 1-inch white gaffer tape, the same thing that you use on the field. And you just layer them one on top of each other. And you can see I have it folded. So this is the top of the battery and the front of the battery. So when the battery is in the compartment, what it's doing is it's forcing the battery down into those contacts. And once you put the battery cover on, which will be a little more difficult than when you took it off because there's a bit of tape in the way and the battery's kind of shifted position a little bit. But when you put that cover on, the tape is also pushing the battery into the compartment as well. So overall, it just takes 2 pieces of tape folded over like that to give yourself probably a much better experience if you've been having those intermittent power problems, especially when moving the driver hub.
Yeah. And always remember, first allows you to use an external battery pack on that driver hub. So if you want to have an additional security measure, you can attach a external battery pack to the driver station. That'll help out.
And that will make your battery management throughout the day much easier too.
Yep. Okay.
I was prepared for that one. Feel good. I can give a little bit of a rant because this is a perfect example. So my rant will hopefully be a little bit shorter than Eric's. But this is something I say to a lot of teams in a lot of different scenarios. I don't know that anyone even, like, if my words even make sense to anyone or if anyone's listening, but I'll just say it again. Eric has heard this before, I'm sure. But tournament day is stressful. And it's stressful on your robot and it's stressful on your people. So when we talked about strain relieving wires, what we're really talking about is giving your wires a little bit of leeway so that when an external stress happens to the robot, like another robot running into it, it doesn't cause you to get disconnected. You have to understand that the way that you practice with your robot is not as stressful of an environment as when you're on the field playing a match, especially at a major tournament like the Florida Championship. So you have to start thinking about what are the ways that my robot is going to be stressed that don't show up during practice. Strain relieving wires is a great example. Moving or having trouble with the driver hub is another great example because maybe you've seen the driver hub lose power before, but you're in a practice setting, so it wasn't a big deal. Like, yeah, that was kind of weird, but we have plenty of time to reboot it. That's just not the case when you're at the field waiting to run your match or if the match has just started. So you have to think in that mindset, like, how are the things that I'm working with going to be stressed in new ways at this competition? And how can I protect against that stress? The other side of it is the people aspect, especially your drive team. You're going to be stressed because you're at a tournament. Things are moving very quickly. There's a lot of things that you have to remember and keep in your head all day. The way that you can combat that is with checklists. Eric mentioned the pre-match checklist. Make it so that your drive team doesn't have to remember anything because it's all written down in front of them. That's how you fight stress at a human level. Make sure you have a checklist for what you're going to pack so you don't forget anything when you're driving to the tournament. So those two areas, like, how is my robot going to be stressed and how can I prevent wires from being ripped out and all of that? And how can I prevent humans from having to remember things in a stressful environment? Those are, in summary, how you succeed at a tournament.
Yeah, you're talking about like. Yeah.
Wait, go ahead.
Yeah, you're talking about stress living wires. One thing that we saw actually on the power cable and even servo wires for the past couple of years is, like you mentioned, if we put it too tight, the actual port where you put the motor into, it tends to expand and they get super loose. Like we have to put so much electrical tape or like gaff tape over it. Yeah,
it does. Like I've seen these JST. Which ones are these? I can never remember it's not the pH, it's the other ones, but these motor connectors, the plastic tab that you see at the top, those get bent out, like you said. Another thing that is a very common problem right now is if you look at the power connector, you see that little pin inside, and you can't really see the lines, but that's like, it looks like the bud of a flower. There are a few pieces that are kind of just a little bit spread apart, and they have to spread in order to make contact with the wire that's sitting on top of it. So over time, that little flower bit of it, it gets compacted until it's really tight, and it's not actually making contact with the metal of the wire that's sitting on top of it. So what a lot of teams are finding, especially on control hubs that have been in use for a season or more, as they get a little bit older and as wires have been wiggling those connectors until they're tighter over time, is you can actually go and tap on the wire and it will lose connection. So if you can do that with your finger, or if I can do that on the field when I'm investigating what happened during a match, then it will definitely happen when a robot runs into you. So one of the things that you can do, you have to be extremely careful, but you can take something like a little push pin and just, very carefully, barely push it in so it spreads that little flower connector open a bit so it makes good connection with the wires. I just mentioned that because that's a common issue we're starting to see more and more as more teams have been using the control hub for a few years now.
And the other thing is that most teams have been to 3, possibly 4 events already in the year. So their bots have gone through a lot of, issues. And so one thing you really want to make sure you do is go through your bot and check everything, check all the wheels, check all the connections, check all the cables, verify that everything. I mean, because like we're saying, you've practiced with that bot for the last 4 months. You've run it at events, so, is there anything that's loose that hasn't been, checked out? Now is the time, a week or so before is the time. If you have to replace a cable, now's the time to do that. If there's a wire that's frayed or anything else, check for those types of things. Make sure that you check all of the connectors. Make sure you check all the connectors to all of the motors and the servos, and make sure that those are good. It's just now is the time to be able to really make sure that your bot is in tip-top shape condition before the state championship.
Yeah, speaking of like the structure of the robot and making sure it's like in good shape, we've seen like often like a lot of teams will have like certain weights on certain parts of the robot. So like how would you ensure that like weight distribution is not like that big of an issue?
I think this is a big issue this year when you're trying to hang, right? Teams will try to lift themselves up, but then the robot just sort of pivots and they're still touching the ground. Go ahead, Eric.
No. And like I said, that's one of the things that practice is going to tell you more of that situation, how that is happening or what it's happening or causing that. And you really want to make sure that you practice, especially, at the end hanging it in various locations on those bars. Just don't say that you're going to I'm always going to go to this spot, because that spot may not be there. That you may have to move over to something else, and you hadn't practiced that. You hadn't been known, or you don't know how the robot's going to behave, because there's, if you go to the one that's closest to the wall, there's the other bar that's down there that, affects how you get to it, how you go under it, everything else. So if you don't practice and know how to adapt to that scenario, that's going to be something that will affect a lot of robots. And like you said, one of the things, besides having been an FTA, I've been a judge in the past, is a lot of judges look for, the math. Did you do the math to figure out what is the force to lift your bot? And if you can show that, that's something good to present to the judges, being able to demonstrate, okay, we did some analysis on the bot. We looked at the forces involved. We looked at how it's supposed to lift. though all those types of scenarios, those are great things to present to judges.
Indeed. Weight distribution is I think a uniquely difficult problem in first tech challenge because one of the size constraints, you are working within a pretty small volume, but also it feels like the best thing that you can move around to change your weight distribution is your battery. But that's also the thing that needs to be the most accessible because you're constantly swapping it out. So that causes an interesting issue, right? And I think a team with a lot of experience may come into this situation and realize that, sure, we have a design. We think we know what we want our robot to look like and how we want it to interact with the field, but let's do another extra step in this design process and another iteration on it, specifically thinking about how we make it balanced while also being usable. So how do we quickly get the battery in and out? How do we still have access to all of the ports on the control hub, all of that? I think that ends up being an afterthought for many teams, and it just makes your life a little bit harder as a result.
Yeah, and speaking to that, also make sure that your battery is secure in your bot. I don't know how many times I have seen batteries splayed out on the field, just there it went, because there was no mechanism to secure the battery properly to the bot. Oh, we'll just put a zip tie around it and let it go. Well, when you're jostling around and things are hitting you and you're moving about and hitting the wall and trying and hitting the backboard, the pixel board, it just falls out. So just that's another thing to make sure of.
And I think you should be warned. Like my job, Eric's job as an FTA, our primary goal is to make sure that if something goes wrong with your robot during a match, you walk away from the field knowing what to do next. Like we don't necessarily have time to sit down with you and fix it because we have to do the next match, but we want to make sure that we do the very fast triage, we understand what the problem was, and we give you advice on next steps. If your robot drags its battery around the field and has a problem as a result, we are legally required to walk over to you at the end of the match and say, that's your problem. So just be warned, that's going to happen.
Yep.
Arnav, any other tips you'd like to know?
I think that's it for me. I know I just have a couple wiring questions. One thing that we've had to implement this year is different office tags. Like on our outtake, because we have a linear side to extend, we have a big just wire sheathing mess that just falls off the side of the robot. So we had to use office tags to tension it back in. Are there any better solutions for that, or is office tags the best thing we got?
There are other solutions. I've seen teams use rubber bands. I've seen teams use just the badge holder extender type of things. Those what you're talking about. So there really isn't a best method that I've seen for that. It's just a lot of teams will have to figure out what works best for them in those cases. I think that those tag extender cables or extender badge holders work fairly well from what I've seen so far. I always recommend that you have an extra one just in case something happens. There really isn't many other ways that I know of easily to do that type of wire management with a long flexible cable that's hanging about, especially for the elevators and having to bring all that wiring back in. Yeah,
that's a tough one. The only piece of advice I want to give is when you're planning it out, as much as possible, keep your wires in the robot.
Yeah.
So avoid the situation where they are like, when it collapses back down, the wires might bend outside of the robot. Obviously, you're not worried about size constraints at that point, but you should be worried about getting tangled up with someone else.
Right.
On the same note as the weight distribution, are there any like software fixes that could be done to also maybe at least mitigate or lessen the issue?
Which issue are you talking about? The weight distribution issue?
The weight distribution.
Yeah, you can. I mean, they're depending. You can have, based on the side of the robot that more weight is on, you can apply more power to that side of the robot. So there are some things that you can do to try to resolve that. However, typically for the most part, I mean, we have a very small bot. It's not really something that's large, and weight distribution is not going to change a lot in that respect. But again, that is something with testing your bot, you'll be able to define and see some of that and how that's occurring. But the only solution that I know of is applying more power to one side or to the other to try to resolve the weight issue.
Yeah, like right now we've been focusing a lot more on our drivetrain because of this. Like we've definitely been focusing a lot more on both the structure and like making sure it's sturdy because of this like prevalent issue. And yeah, I'd say probably we'd just go with like, as a solution to that, many teams could probably go with like tuning constants according to their robot.
Yeah.
Yep. Yep. And yeah, because when you use something like PID control, like we have available to us when you're using encoders on your drivetrain, depending on how much load each motor is on, it will respond differently. And the motors will end up at the same encoder clicks. If you're thinking about, let's just imagine a typical tank drive robot, two sides operating independently. The encoders will end up in the same place in the end if you want to drive forward, but